Getting over the fence a little bit, just a bit. I guess I'll get going. Um, I would expect that we'll go through this whole time period, okay? Feel free to ask questions. I'm not a real formal person, okay? So, casual, there's enough of us here, and I think I stepped out and introduced myself there. That's up to every one of you. So Emerson as a whole, I put in a slide here just to kind of give you an idea of who Emerson is. So this is a 21, and just at a glance, we are headquartered in St. Louis. This moves as we either divest or invest in companies. We are a conglomeration, so we kind of ebb and flow in our total employee size. About 170 manufacturing facilities as you go global, okay, depending on what we're doing. And we have different centers of excellence that we might focus, like Minnesota might be our transmitter group. We might have a flow group in Boulder. We might have our Center for Excellence for our control systems is here in Austin. Okay, it's up in the Round Rock area, just north of here. But globally, you can go through a full portfolio that's quite large. It's roughly 2 business divisions in our platform level. This group right here is the one that I'm associated with. This one right here, as you see, is commercial and residential. And you might see the little EVR type logo of Emerson on different things, maybe even at a Home Depot. You're looking around at different products, and those would tie into this area where you might find them at your home. Like I have a couple of thermostats because I couldn't buy the H1. So again, I'm here, and then we're up 18.2 billion. Again, that kind of fluctuates, but that's the total as it ended in 21. And our fiscal runs October 1st for 12 months, right? So we're a little out of phase with the calendar by quarter. We did participate in quite a few things I'd like to call out as it relates to, our current situation in the pandemic, and some of our automation solutions provided a lot of the vaccine content that you might see out, and they pull that over as a comprehensive piece of the slide. We have increased dividends if you're an investor over the last 65 years consistently, which is very rare if you track how long-term investments go as dividends are concerned. Every single year for 65 years, we have increased that, and that's largely because of the success and collaboration with our clients is what's allowed us to do that. This is our ticker symbol. And then we do have, working with our engineers and with our clients, we come up with solutions to solve problems, and we maintain a pretty healthy backlog of intellectual property as it relates to the active patents, et cetera, worldwide, about 20,000. That's quite a heavy load there. And then as you look at Fortune 500, we're 181, so we're pretty substantial in our size. And then we look at awards and recognitions, and probably the most recent, we're very, very open and collaborative in our employment, extremely, as it relates to some of the different focal points. And then diversity and inclusion, of course, and then IoT analytics. There's been so many words that's been labeled as we evolve into the digital world. And we just track along with it and continue to explore and develop as we go. And we, get accolades, et cetera. And then recently, was anybody here last year that participated last year? Okay, last year we had Mike Train here as a keynote speaker. Okay, and Mike Train is our new sustainability officer. So as we focus very heavily on emissions and greenhouse gas, et cetera, we've taken it to a pretty high level, and he is at the C-suite, so he's reporting directly to our CEO, and that transcends amongst the entire corporation in the hundreds of thousands that you saw, or 100,000 plus of our employees. So this has got a QR code. You get these slides if you want to go back. It's a real short clip, and it kind of gives you the idea of what we're focused on. And the pillars that we look at is greening of, greening by, and greening with. Okay, so it kind of gives you an idea of who we are culturally is the goal here. And I wanted to include that because frequently what I see is as we're going through these cross-departmental engagements, I do normally find that a room doesn't have a lot of knowledge of Emerson, when in fact, your plants are probably very much full of Emerson content. It's just a different group of people that might be engaged at different times. So that's why the first couple of slides sit the way they are. Now, I'm Warren Merriman. I'm the business development manager for refining specifically, and my scope of responsibility is Canada and the United States. So roughly about 25 refineries across Canada and about 125 in the United States. Now, as we all know, those names change. Some become terminals. They move around a little bit, okay? They shut the doors on some, so they never pin down a number. But generally speaking, that's about the scope and the size. At one time, I think we had a little over 20 million in capacity for crude and refinement in North America. I think we're probably running around 16, 18 now. It has come down a bit, but it has come up quite a bit as we've started moving around in automobiles and airplanes again. Obviously, we see the shipping that we're having issues with. The congestion isn't necessarily as slow of the norm. I think it's probably an increase as well. There's a lot more consumption going on in bunker fuel and things like that. And you might see some touches there if you for a while. The IMO 2020, I think, really focused on tied to delayed cokers. Became very important in the space of refining during those days. At any rate, that's who I am. I've been with Emerson now for almost 28 years, been quite some time. And when I started, I have a degree in business management. I learned engineering by the School of Hard Knocks. So they put a hard hat on me, kicked me out of the office and said, go to the instrument shop and be careful because they will eat you alive. So it was quite fun and a good education. So today, again, I'd mentioned that I have very, very few slides. So please jump in, interject whenever you go as I'm going along here. But we'll talk a little bit about tank dewatering. You know, what is it? What are we seeing with it? Some of the solutions. Everything that you see here is actually a case study of something a client did. Okay, so this isn't a proposed or a philosophical, it's actual, it's been installed, and it was presented by myself and the client at one of the Emerson exchanges. And that's an annual show that we have where we bring our clients together and they cross-pollinate their successes. So when Steve saw the presentation and talked to me a little bit on the phone, he goes, I want you to present that in my conference. And Marcio, sitting in the back of the room, walked in here. He's also in Emerson's organization. He's global refining and petrochemical by responsibility. So he might have plus or minus a percentage, about 660 refineries within his scope of influence. So we work and partner together on the domestic individual, if you will. And then we'll go over a little bit of the benefits, okay? And then we'll summarize real quick. So typically in the tank farm, we don't get a whole lot of investment. Okay, there are areas that have some risk and they get a lot of focus whenever an uh-oh happens. Okay, but there are some things that happen along the way that we need to be a little conscious of that might merit some investment. And not only from a risk mitigation, but just from a good corporate citizen taking care of the person there. And then the overall accounting within the facility tie in as well. So typically in a tank dewatering, in a refinery space, and there are many more with regard to tanks, but I'll talk about it. That's the world we live in. So you've got your storage tanks that are your hydrocarbon feedstocks, and we'll focus mainly on that while we're talking today. Then you have some intermediates, and then you have finished goods. As you go down that list, you also go down in the content of the water. So you're going to get most of your water up front when you're bringing your crude. When you start processing and refining, that's your intermediates, you're going to start really getting rid of water. There's some ingress that happens, but you're reducing it a lot. And by the time you get to finished goods, I hope we're not shipping fuels with water. Okay, so that's why it kind of tears down, and you'll see that the focus is really predominantly on the crude side as they're looking at the tank farm as a whole. I've been in tank farms that are huge, and I've been in some that are really small. And sometimes I see a refiner that might outsource a tank farm, and they may lease some tanks from a battery of a third party. But most of what I see is in the complex of the refinery. And sometimes I even see, I believe in your plant, you actually have them across the road. And I think you pull your water draw by truck, if I remember correctly, and then bring it physically over. Okay, so this interaction would be interesting. So over time, the water separates, and I'll show a picture of that in a minute. And then the water is drained off the bottom. So when the crude comes in, it's going to have water inside of it, right? It's going to be suspended in the crude. So it's going to sit for a while if the tank is stagnant, and it's going to get a good separation, right? And that's what we're pulling off the bottom. Okay. Now there are manual ways of doing that, and I'll talk a little bit about that. Everybody know what olfactory is by term? Think about that for a moment. So there's some potential risks as you go through manual processes. You do pull the water and go to a sewer system, and then you go to a treatment, and then you end up in an effluent treater, and then we're back out to the environment, right? Generally speaking, very, very broadly. What we're trying to do is we're trying to eliminate how much hydrocarbon breakthrough we get whenever we move that water out of the tank. So of course, the oil sits on the top, the water sits on the bottom. We're going to de-water from the bottom. And then we're going to see different physical anomalies that are inside the tank. And I've got a little pictorial of that in a moment. So the potential is the risk of this, the risk of the VOCs. And then this is an additive benefit that this customer discovered. There's an overall fence line mass balance requirement that happens in a refinery that was an additive benefit. So as we're working cross-departmental deliverables, you'll see the instrument group might benefit in one way, the operator in another. And then ironically, you've got your accounting people as we're trying to watch an overall environmental impact. So you'll start lining up with a whole bunch of benefactors to that investment that you make whenever you start looking at this solution. So current operations, some of the challenges, you typically have got an operator going out manually until someone has found a reason to automate. I see a lot of them are still manual. It's not uncommon at all to see that someone's physically going out and pulling a draw, and there's just a valve there. They're turning the valve until they think the water is gone, and then they close it out. Very common. And you get varying degrees of results that depending on who the individual is that might be going out and doing it. Okay. Now, this term here, naphtha, can you visualize what naphtha looks like? You ever seen naphtha in a glass jar? It's opaque. Looks like water. Physically looks like water. Okay. So when your operator goes out there and they have a piping that comes out and it drops into the drainage, they're frequently smelling for the hydrocarbon. Turn it on, it don't smell anything. And all of a sudden I smell it, okay, close the valve. I've got to the bottom of the hydrocarbon, my water's gone, and I'm starting to flush out hydrocarbon. Okay, it's the olfactory, believe it or not. And that is another varying degree because typically the lack of frequency that will go to a tank farm will cause that operator, while he opens the valve, to go take care of other assets that are in the area and inspect other things because of the frequency that they're there. So we're dumping, we're waiting for a smell, and we're on the other side of the tank. When we come back, oh, I closed it off. How long is that going to go? I don't know. Start closing. According to what the work orders might be during that draw period. And there'll be a process and a procedure. Go check the pumps here. You know, if you sat through the prior one, I don't have to go into the details of what you might find on a tank that needs some attention while you're standing there. Okay, lots of things that are there. So the risk is that you're gonna drop it in the sewer and you've got VOCs, and so your operator's harmed. Then your effluent treater is where this discharge will go. Now that runs with a biology that is over my head. But if you hit the bugs, as we call it in the instrument shop, School of Hard Knocks, too much hydrocarbon, you kill them. And you totally upset the effluent treater as you're pushing material there, okay? And I don't profess to be an engineer, but I know this happens because I run around the plants enough, okay? Now, when they do that, or they risk doing that, they might have to go buy hydrogen peroxide, I believe, at a very highly rate, or a very high rate of cost, in order to infuse and oxygenate to keep the bugs alive. Doesn't sound like you. Okay. I'm waiting for somebody to go, hold on a second, Warren, you need to learn this data point. But that's generally, in layman's speak, what's happening as we're trying to dewater this tank. So there are mass balance issues, because as we watch product coming in, mass is neither gained or lost between the in and the out. It goes somewhere. Now, there's an overarching entity that grades each refinery when they submit data amongst a matrix of information called Solomon. And Solomon will grade each refinery and determine how they sit in the quartiles of a whole bunch of different measures. In order to play in that sandbox, you have to be able to demonstrate that your overall fence line mass balance is within 0.5%. Otherwise, they say, if you can't figure that out, we don't believe anything else you do. If you don't know you're in and out, you don't know what's going on, I don't believe anything you got here. At least you have to know that, because they're really not in the business of making fuel. They're in the business of making money. That's the definition of business. Right? That's what they're there for. So if you don't know the dollar coming in and the dollar going out, they say you're not well enough versed to be able to do that. Now, I skipped over a couple of things here. Of course, you're a trader, and the possibility of fines. And, we regulate to make sure that we're overall safe to the environment whenever we're watching how a refinery is producing. And we're getting much more efficient at understanding how to reduce that carbon footprint. Much, much better as an industry. So the solution that they came up with was, as you're looking at the tank, you have your overall oil that sits on the top, and then you have your water on the bottom, and this is where your draw might come out. Well, this little area right here of emulsion is where, when you have agitation, you don't have a good stratification or separation of the liquids. So if I'm sitting here and I've got a manual valve and I'm waiting for some smells to change, I don't know if I've began this or if I'm ending that in my tank. Okay. And I might get an increasing smell as I start working my way through the emulsion until I get a certain percentage or concentration that actually comes up and smell it. But I'm physically looking at it if I'm standing there, right? We talked a little bit about that risk. And I'm smelling for it. That's the gauge that you might see. So in the case that this client used, you look at this meter right here. It doesn't require any upstream or any downstream to be accurate. If you ever study flow measurement, those are some of the complications that you get whenever you're looking at the flow measurement technology solution. Okay, there are many, and you really have to pay attention to what you're choosing. That's why you have an idea. Okay, but overall, how do you get funding to support an environmental inclusion that benefits multiple? Is really what we're trying to talk about with the business case. So in this particular case, the mass flow rate is 0.10% of rate. Okay, that's super tight. And then density, plus or minus 0.0005. We're talking about the gnat's eyebrow here, right? Teeny tiny. We're going to see everything we need to see with that instrument, beyond a question of a doubt. And this is in the actual meter body itself. So the makeup of these is that you have the meter body, and then it's accompanied by a transmitter on the top of it. This particular device right here is connected to it, so it can send out a wireless signal that gives you additional data. I'll cover that in a minute. But you have a device here that's your meter, and then the device here that is your transmitter to send it out to the control system or the SCADA system or whatever you're controlling or measuring off of. So we're going to set a trigger point within that measurement to say, when you hit this point of hydrocarbon breakthrough, I want action. Out, or I want to illuminate a light. So if I'm standing there and I haven't got enough money to invest in the control system to close the loop, I'm still using a manual operator, but I'm giving him everything he needs, or she, to turn that valve at the right time. And the goal that this client had was no more than a 5% breakthrough before they activated a light or a motor operating valve. Okay, so they did have both solutions. As they were moving their migration through, they ran through a section of some tanks, and then they moved secondly through the rest of them pretty color ranked, and then came with the budget as the years went by until they finished the job and their whole tank farm. You'll see that in a second. So the thumb brings in the inventory analysis. Okay, so you get that additional data. So the overall transmitter comes in and it gives you the control of what you're trying to do. Then your thumb gives you the additional inventory analysis, which ties back to that solid index I was mentioning. So now you get real-time analysis of the water and the mass to the sewer. Now, the guy that put this together said, you know, sometimes we get these, and he called it a snotty tank. And what that means to him, and again, I'm quoting him, he said, whenever we have multiple ways of bringing crude to the site, whether it be by barge or by pipeline, for example. Well, in the case of the pipeline, they have tanks upstream on the pipeline where they have holding, right, in the midstream business. They get upstream, midstream, and downstream, for downstream here. In the midstream section, they'll have tanks that they have in there. Well, periodically, those tanks come down for cleaning. Well, when those tanks come down for cleaning, they fill them up, and the first person that gets the shipment down the pipeline of that tank, it's a rocking sensation that's going on inside of this tank with this gun. It's with this gun. And that's what he calls a snotty tank. He said, when we get those come through, and you never know who it's going to be, but somebody's getting it down the line, and your turn comes up. Eventually, your turn comes up. And that he says we have a flow that's constantly going to our treater. This brings in a huge increase whenever we do that, and we have all kinds of problems in the treater, and it upsets the whole refinery. So another additive thing as you're pulling off, as you see influx of different materials coming in and out of your, what otherwise might be considered crude feed. Now, the other thing that happens is from a tax basis, you're taxed on your feedstock. And if you're pulling water and you haven't done a mass balance to figure out how much water is there, you're taxed on the water just like it was crude. And you're moving 160, 180,000 barrels a day. You're paying a lot of money in taxes. I don't remember what your capacity is. You're probably at what, 3? I don't remember. Okay. Let's just say that it's substantial at $100+ a barrel and 180,000 barrels a day. And what percentage they're taking in taxes? You do the math real quick. These meters are nothing. Okay. Now, they may be hard to go get an AFE approved and find the money to spend on your need, but in the greater good of what you're looking at, they're really not much. When you start cross-departmentally looking at the benefits, it becomes much easier for operations to say, okay, this makes sense because you're not coming at me with one solution. You're coming at me with a multitude of solutions, and that I will invest in. So just as you're thinking about the investment process. Okay, so how does this little meter work? It's Coriolis, and you have the flow tube, as I mentioned before. So it comes in the flange, it moves through these tubes, and then out. That's how physically inside of the box that you can't see normal. Then as you come over here with the transmitter, you have all these different outputs that you could get out of a transmitter. And normally your transmitter runs off a current signal, and you get one process variable. When you put a phone and you include digital transformation, IIoT, or whatever it is that's allowing you access to money in your plants, okay? This is how you instrument that to tie into all these other needs when you have a wireless infrastructure in your tank and you're limited to one wire of process variable information. You can open up all these other channels that serve different departments. Very, very inexpensive to add a thumb to a meter and put in a wireless gateway because you're not home running all these tanks. It can be very costly to do that. Again, as you're trying to look through your value proposition. Now, physically inside of it, your flow came in. This is the cross section of that meter again. And as you come in, there are two tubes. One is hidden behind the other because of the orientation of it. There is an upstream tube sensor here. There's a downstream tube sensor here. And then there's a coil drive that will cause a vibration inside. Now they call these things micro motion meters. That's where it comes from. It's a really small, slight vibration that's happening inside. And it's got a physical motion that's happening. Now, when you're during no flow conditions, the flow tube vibrates in phase, these two tubes, okay? So when you look at it on a oscilloscope, they're in phase. And that's saying we're at our natural frequency that our coil drive is pushing, and we're just vibrating there at the same frequency. Now, when you run a flow through them, you get a phase shift. Okay, so with flow, the Coriolis forces are induced, causing the flow tube to twist in opposition to each other. I like to say, how many times do you see a fireman standing with a nozzle with only one person? It's usually two, because the mass coming through that fire hose will take one person off their feet. And it is the Coriolis effect. That's what's happening physically. So you take that down to a micro motion, and now you start seeing how we're using the physics. Okay, and that's generally how it works. A lot of people look at it as super complicated because they don't understand that's all that's happening inside of us. Okay. The way this particular client put together their calculations, because you have a variety of different tanks with a whole bunch of physical content in them, right? So each of them has a different API gravity. Now you look these up on the internet and figure out what they are. Okay, there's tables and charts, and you don't have to do the math on this stuff. It's all been done by someone. So probably API. So there's a correlating specific gravity for each of the API oils. In this case, this is their crude calculation. But what this man did was he put together a chart where these were variable, and it automatically counted these because he had tables behind it. And therefore, he could walk up to any tank with any content, solve for no more than 5% hydrocarbon breakthrough, regardless of what gravity or API of the process fluid was in the tanks. And he just mapped the whole place for them. So in this case, you would say, I'm going to have an API gravity of my crude that's 60, which is a corresponding specific gravity of 0.73. Then I'm going to look at my water, which has an API gravity of 10, which is specific gravity 1. And then I'm going to solve for only 5% hydrocarbon. So I take the 5 for my oil, and I get my 0.03. And then I take my 95 for my water, and I get a 0.95, and I add them together. And now I have my specific gravity. Then I go back and I set my trip point at 11.87. And you real quickly got exactly how to engineer your solution, regardless of what fluid is in the tank, with the stipulation that you're not going to allow more than a 5% hydrocarbon breakthrough. And that was the solution he did. Okay. Now, inside the transmitter, there is an API software that converts density at line conditions back to standard conditions. That's for the board operator, if that's of interest. So in this case, this is a motor operated valve on the side of the tank. This right here is your Coriolis meter. If it were me, I would have oriented this down instead of sideways, because I don't want any air to get to it. Now, your tank's probably full, and if it's got enough back pressure on it, it's not gonna have a problem. But just general good practice says, let's locate those tubes down when we're in gas. Okay? This is the manual setup. So in this case, you're connected to a control system. So I have my measurement point, I have my primary element, and I'm able to move them back to a control system, and I can remotely operate and control them. As I look at a manual system, I might have this illuminating a light. So I couldn't afford, in the budget constraints given to me, to put these on all my tanks initially. But I still have someone coming out and I want them to have the same result. So I put the meter in, I have the meter illuminate a light, and now I can manually close it off. And I end up with the same business results from manual as I do an automated, and I can work my way through whatever constraints I have in my budget and still get the same. So we remove the variations between the process and the operations. The result they ended up with, less than a gallon of hydrocarbon on every drawdown. That, to a person running a tank farm, is significant. Okay, I can't emphasize the result of that is large. I would challenge someone to go back and ask, what do you typically see? Will not be anywhere close to that. He was glowing as he was doing this presentation. Okay, that was significant. Now you eliminate your VOCs for the operator, and then as you're creating, your overall VOCs across the plant, as we all know, we got to reduce those as good stewards in the industry and keep decreasing our carbon footprint. So we're protecting the person, we're protecting the environment as well.
So what was it, like a barrel before? To that gallon, you think it was that much?
He wouldn't commit because of the variability from person to person, and because the person may be on the other side of the tank, and frankly, I don't think he wanted to admit that. But he was glowing at the result. I think it was maybe a little bit revealing when they finally got it down to realize what was happening. And it was all these situations or circumstances that caused that situation. And it's not unusual when I go out to a tank farm that I see that it's underinvested, because it's difficult to quantify an ROI in a tank farm. You can really quickly calculate when you're doing distilling or converting. It's super easy to do. But when you get to a tank farm, it's like, do I really need a new battery for my car, or can I make it? My tires are getting a little low, but it rained yesterday and I didn't have it. Maybe I can make it. Right? I mean, it's just one of those things in the tank farm. And this is my last slide. I think the rest one is,